In this lesson, we're going to be looking at placing fractions on a number line, but we're going to be staying within the whole, so we're going to be going up to 1. And you're going to be recognizing that the denominator represents the number of parts that number line has been broken or partitioned into. And that's going to be the big learning point in this. So we're going to be able to look at that denominator and then using the numerator to work out where it needs to go on that number line. So opening up our textbook, we can see our first problem is going to relate to the image on teacher's interactive whiteboard. Now both these questions are going to lead on from each other, so it's important to get question 1a correct before moving on to question 1b. Don't try and jump the gun on this one. Always start with that 1a because it's going to break it down into the steps we need to look at. And for question 1a, we can see the question is how many equal parts has the number line been split into? So we can see that number line that starts at 0, finishes at 1. How many parts has it been split into, and what does each interval on that number line represent? So when we move on to question 1b, we can see that Miss Hall is given as a statement, I'm thinking of a number that one of the arrows is pointing to. Can you guess my number? So question 1b is asking what could Miss Hall's number not be, and what could Miss Hall's number actually be? So this is going to be where we're going to use that information from question 1a to help us. Because in question 1a, we've worked out how many parts of the whole number line is broken into, which will lead us to understand what each section, each interval on that number line is worth as a fraction. From that we can start working out how we can record those as the actual fractions on that number line and position them correctly, knowing that the numbers that Miss Hall isn't thinking about are shown as blank, and the numbers that she is thinking about are those ones with arrows. So we can start working out which fractions she's thinking about and which ones she couldn't. Think about whether there could be more than one answer to which number Miss Hall could be thinking of. So now pause the video and I want you to complete question 1a, which is looking at the image. How many equal parts has that number line, that whole, been split into? And then thinking about your fractions, what does each interval on the number line represent, and record that as a fraction to help you. That moves on to question 1b, looking at that number line, thinking which numbers could Miss Hall not be thinking of, thinking about the statement she's done, and then which numbers could Miss Hall be thinking of. And on that one, think about whether there could be more than one answer. So now pause the video and come and join me again when you're ready to look at the different strategies. So question 1a was asking how many equal parts has that number line been split into, and what does each interval on the number line represent? So let's see the strategy we can work on to find out this answer. So here we can see our number line. It goes from 0 to 1. There's one number line, so it's almost like we've got a whole bar on this. And what we're going to be thinking on with this is how many parts has it actually been split into. And looking at this number line, we can see that we've split it into 1, 2, 3, 4, 5, 6, and 7 parts. And we can represent this as a bar as one whole bar split into 7 parts. And of course we know that if we split it into 7 parts, we're looking at a denominator being 7, and each of these is worth 1. And we can see, nice and simply, that each section of my number line now is worth 1/7. So how many equal parts has the number line been split into? The answer is 7, which means we're working with a denominator of 7, or sevenths. And what does each interval on the number line represent? Is one of those sevenths, or 1/7. Now for question 1b, we've got Miss Hall saying, I'm thinking of a number that one of the arrows is pointing to. Can you guess my number? And we're asked two parts to this question. What could Miss Hall's number not be? And what could Miss Hall's number actually be? So we return to our number line, and of course we remember that each part of these is worth 1/7. Now nice and simply, all we need to do is count up in our sevenths to work out what our answer could be. Now what we can do is we can return to our counting skills of 0. Our next is going to be, if we're counting in sevenths, 1/7. The next one, 1/7 and 1/7 will give us 2/7, 3/7, 4/7, 5/7, 6/7, and finally 7/7, which will give us 1 whole. Now, remembering that Miss Hall's statement was, I'm thinking of a number that one of the arrows is pointing to. Can you guess my number? We know that when she's asking the question 1b, what could Miss Hall's number not be? It means it's one that we don't have an arrow pointing to, which in this case, the only one we actually have is 3/7. And that means each fraction which the arrow is pointing to must be a possible answer. So we have 1/7, 2/7, 4/7, 5/7, and 6/7. So what could Miss Hall's number not be? It's 3/7. And what could Miss Hall's number be? 1/7, 2/7, 4/7, 5/7, or 6/7. So before you continue in your textbook completing the rest of the questions, let's have a quick recap on those strategies. So how do I position fractions on a number line? Well, the first part was how many equal parts of the number line being split into. We're going to work out what fractions we're actually dealing with. And we can work that out firstly by thinking there's one whole. How many equal parts is it separated into? And in this case, we can see that it's separated into 7 equal parts. Now we understand that we've separated it into 7 equal parts. That means each part must have a denominator of 7. And if we're looking at each part individually, each part is going to be 1/7. So we have 1/7, 1/7, 1/7, 1/7, 1/7, 1/7, 1/7. Put all those 7s together and it gives us one whole. And then once we've worked out how many equal parts the number line has been split into, 7, what does each interval on the number line represent? 1/7. Then we can work out what fraction is each interval on the number line. In this case, we're just going to be counting up in 7. So 0, 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and one whole, or 7/7. The same would be if I split it into, for example, 2 parts. My denominator would be 2. Each part would be one of those 2, so 1/2, and then I would simply have 0, 1/2, 2/2, or 1. And I'd be able to position them whether I split it into 3 parts, 4 parts, 5 parts, 27 parts. The same strategy is going to work. So when you're working out the following questions, remember, be thinking about how many equal parts is that number line being split into, what does each equal part therefore represent, and what is each fraction of the interval valued at. So good luck, work through those textbook problems, and when you're ready, move on to the independent activity, and I look forward to seeing your answers for this one.